Now there are a few different types of functions that you've experienced over the last few years. We'll start with linear functions. A simple way of writing a linear function is in the form y equals mx plus c, where x and y represent a coordinate, m represents the gradient or the slope, and c represents the y-intercept. So in the case of y equals 2x plus 1, this equation represents coordinates x and y, where y is related to x, by a gradient of 2 having a y-intercept of 0 and 1. If we were given a different linear equation, 2x plus 3y equals 1, which is not in slope-intercept form, we can rewrite it in slope-intercept form by subtracting 2x from both sides, dividing both sides by 3, which is what this is here. Now we have a gradient of negative 2/3 and a y-intercept of 1/3. Two special functions that we should know is y equals a and x equals b. Y equals a, or in this case y equals 2, it's a horizontal line, and can be rewritten as y equals 0, x plus 2. If there's a gradient of 0, that's a horizontal line, which would give you a gradient of 0 and a y-intercept of 0, 2 in fact. All the coordinates on that line would be in the form of x, 2. Similarly, x equals 5 is a vertical line with an x-intercept of 5, 0. Be careful with this one, it's not a function, as there are multiple values of y for one value of x. So all linear functions will be drawn as a straight line. Now, something that's quite handy is if you have a straight line, you should know this button over here, because that will set your domain and your codomain. And you can get from writing the equation here to drawing the graph by pressing that button there. Now, if you wanted a table of values instead, you still put the equation as per here, but this time you'll press this button to set the values that you're looking for. In this case, we're looking for x values between negative 9 and 9 with a step of 1. We go OK, press the table button over here, and it will spit out a table of values that you can look at. Now, with a linear equation, I suppose up until now we've looked at an equation which will have a highest degree of 1. The power of the x value can be no higher than 1 for a linear equation. In fact, it has to be equal to 1, can't be anything else. We've looked at a graph, here it is here. We should also look at a table. So if we have the equation y equals 2x plus 1 and we want a table of values, in this case we've got a special table called a difference table. In a difference table, the x values increase by 1 each time. And in a difference table, if we take the difference between the y values and put them into their first difference column, these values should all be the same, and in fact will be the gradient. Now if we find that we've got a constant first difference for a difference table, it's a linear function that we're looking at. Similarly, a quadratic function, rather than having a degree of 1, this time we're going to have a degree of 2. That's the highest power in our polynomial. A quadratic can be written in 3 forms. Standard form, y equals ax squared plus bx plus c, where 0c is the y-intercept. In factored form, y equals a, x take d, x take e, or you can substitute any variables for d and e, where d, 0 and e, 0 are going to be the x-intercepts or the roots. They're known as both. Or turning point form, where y equals a, x take p all squared plus q, where pq is the turning point of the equation. All 3 forms, if a is greater than 0, the graph will be concave up, and if a is less than 0, the graph will be concave down. Over here we have y equals x squared plus 2x plus 1. It's concave up. It has a turning point of negative 1, 0. And a y-intercept of 0, 1. Now, if we put a quadratic equation into a difference table, remembering that a difference table is something where x increases by 1, Second difference, so the first difference is found by finding the difference between the y values. The second difference is found by finding the difference of the difference between the first differences. If this is constant, that's indicative of a quadratic equation. Later on we'll learn some more information about this table to make it easy to get from a table of values back to an equation, but at this stage we're not expected to know that. A third type of function would be a reciprocal function. So in this case it has a graph that looks like this. It's a right hyperbola. And these equations are written in the form of y equals k on x, or xy equals k, where k is some constant. If k is less than 0, the function is reflected, and it would be here instead. If we put our reciprocal function into a difference table again, as you can see, x is going up by 1 each time. You can see that if we multiply x and y together, we get the same value for everything other than the undefined value where the asymptotes exist. And that's the end of us looking at functions for now. So thank you, everybody. Next we'll go on to our something else.